In this lesson, we're going to talk about all the key features of exponential functions. So in other words, what makes exponential functions unique from others. And so exponential functions are already very exciting in themselves because we don't have just one parent function, we have two parent functions. We could have growth exponential functions, or we could have decay. With growth functions, we say the graph increases very rapidly. So it's going to look something like this. We're going to start really low, and then suddenly we're going to shoot up to become very big numbers. In a decay, the graph decreases, so it's just the opposite. We're going to start really high and then come back down to a base level line. So these are our two types of parent functions. We could have growth or we could have decay. And some vocabulary, some new and some old. Domain is all of the x values in our function, and it goes from left to right. Range is all the y values in our function, and it goes from bottom to top. So those should be familiar to us by now. The y-intercept is where we cross the y-axis. So like on this graph here, I could say this is my y-int, because that's where the graph is crossing this y-axis. An asymptote is a new word. Asymptote is a line that a function cannot touch or cross. So we were talking about in the at the beginning, we have this line that's kind of like our baseline level for our exponential. So everything else is going to be above it or below it in some special cases. But here, an asymptote, we can't go below that line. So we're going to get really, really close to it, but we can never actually touch it. And so this asymptote is going to be really important when we start talking about domain and range. So domain, I see I have these arrows at the end, so that means I continue left forever and I continue right forever. So I'm never going to have any domain that's not all real numbers when it comes to exponential functions. But the range depends on the asymptote. So let's draw this asymptote in here again. So we're going to get really, really close to this line, but we're never actually going to touch it. And so everything else is above that line. And so we're going to write that as y is greater than the asymptote, which we're going to call k. Okay? We're not going to put the line underneath it because the line underneath means that we are touching that point. Which is not going to be the case with asymptotes. So all of my y values of the function are greater than my asymptote. Okay? And so we're going to look at two examples of this. First, let's do this from a graph. So the domain, we said it was really just all real numbers, and that's the case for all of our exponential functions. Before we find the range, let's find the asymptote first. So the asymptote is that line that we get really, really close to. And you can really just see it on the graph here. I can see that this graph stops really going down right here, right? And so it may look like we're touching it, but that's just because we're getting infinitely smaller to that point. And so my asymptote here, we're always going to write it as y equals, whoops, that's for range. Asymptote is y equals, and then the value that I crossed through on my y-axis, which in this case is just 2. So this is the asymptote of my function. And so everything, all my y values here are above this. And so my range is going to be y is greater than 2. And last, my y-intercept, I'm just looking for where the graph crosses the y-axis. And I see that we are crossing right here. That point is 0, 3. And so my y-intercept is 0, 3. Let's do another example now, but this time we don't have a picture of the graph, but we do have an equation. And we do have a very powerful tool that we can use to get a graph from an equation. So I'm going to switch over to Desmos now. And so let's just type in the equation. We've got f of x is equal to 3 times in parentheses 1 divided by 2, close the parentheses, raised to the x power minus 4. And I see I get this purple graph here. This time we have a decay function. Since it's going down, it's decreasing really quickly. So for my key features here, domain we're going to say is all real numbers. Again, that's the same for every single exponential function we have. My asymptote, I'm looking for where we stop going down. And so see here, at -4, I see I'm getting really, really close to that line, and I kind of stop going down there. And if I kind of travel along the graph here, I see that my y value keeps getting really, really a lot closer to -4, but we're never actually touching -4, right? I just keep getting smaller and smaller as I go. And so that means my asymptote is y equals -4, which means my range, again, I can see that all of my graph is above this -4, right? I can zoom this out forever and nothing is going below that value. And so my range is y is greater than -4. And my y-intercept is really easy with Desmos because I can get these gray dots as little hints. And I'm looking for where we're crossing my vertical y-axis here. And so I can click on that gray dot and see my y-intercept is 0, -1. And so exponential functions, we've got two different types. We can either be increasing really quickly and have a growth, or we can be decreasing really quickly and have a decay. The domain is always all real numbers, and exponential functions are really cool because they have an asymptote, which is kind of the lowest value of that function, and we can't even touch it. But that helps us find the range, because the range is always everything above the asymptote, and the y-intercept is where we cross the y-axis. So I hope you had as much fun as I did talking about exponential functions. Good luck in your practice, and I'll see you in the next video.